last word problem says a 0.0005 gram feather falls through the air with an acceleration of 7 times 10 to the minus 3 meters per second squared. Find the air resistance on the feather. So writing down the givens, you have 0.0005 grams. This is a mass. And you have 7 times 10 to the minus 3 meters per second squared. That's an acceleration. And we're trying to find air resistance, which I'm going to call Fr. So let's draw a picture to see what's happening. This is the ground, this is the feather. The feather has a mass m. Anything with a mass, gravity is always acting downwards. With the weight, that's going to pull it down, so with the weight Fg. And here, there's air resistance, and air resistance is going to want to slow down the downwards motion, so air resistance is going to point upwards with the force Fr. And the feather is accelerating downwards at a rate of 7 times 10 to the minus 3. And again, down here, since we know the number down is negative, so A is going to be negative 7 times 10 to the minus 3. And we're trying to find air resistance. So first what we'll do is convert mass. So you have 0.0005 grams. So to convert, you put a bar. Gram is on top, gram is on the bottom, and you cancel. And we're going to go from grams to kilograms. And the conversion is 1 kilogram has 1,000 grams. So the mass in kilograms is going to be 0.6 zeros and a 5 kilograms. Alright, so now we can apply Newton's second law, and we'll do it in steps. First thing is just to get the total force. So step 1, get the total force. And there are two forces here, so the total force is going to be the unknown air resistance Fr and a downwards weight minus Fg. And now step 2, then you set this equal to mass times acceleration. So then Fr minus Fg is going to equal mass times acceleration. And we're ready to go. The only other thing is we can replace weight with mass times g. So the equation is going to become air resistance minus mass times g equals mass times acceleration. So you can plug in here, but it's going to be a little messy because the mass is so small. So I'm going to do some algebra. I'm going to move the minus mg to the right, so minus mg on the left, so add mg to both sides so that they cancel. And so then air resistance is going to be ma, or mg here, plus ma. And the other thing is take out the common factor of m. So then air resistance is going to be m times g plus a. And so we can plug in here. Air resistance equals the mass, which is 0.6 zeros and a 5, and then multiplied by g, which is 9.81, and plus the acceleration, and the acceleration is a negative 7 times 10 to the minus 3. So it's going to be a negative 7 times 10 to the minus 3. And calculating that is going to give you an air resistance of 0.5049 newtons.